Monomials products and students? Do you remember this? Is this true? No. No, Jesse, no. What do you have to do when we square a binomial? Write it twice. X plus y, and then we FOIL. So be x plus y times x plus y. And then we use distributive law or FOIL. Okay? All right, so moving on, let's look at 4.2, so investigation. Use factoring and elimination to write three rational expressions that are equivalent to the following. So is there anything here we can factor? The numerator or the denominator? Not monomials. We can't, like, we could, I mean, I guess we could write it as -2 times 6 or something, right? But when we have two terms, what are we going to ask ourselves? First question, is there a GCF? First, is there a greatest common factor? So is there something we can divide both those terms by? Even bigger. Even bigger. What's 18 and an x squared? Is it coming back to us? Not really. Okay. So remember when we factor something out, it goes in front of the brackets. We want these to be equivalent. We want to figure out what's left over. So you might want to write over 18 just to help you out. We're dividing each by 18x squared to figure out what's going inside those brackets. What is 18x squared divided by 18x squared? Or anything divided by itself? 1. Anything divided by itself is 1 plus 18 divided by 18, and then x cubed divided by x squared is just an x. Okay, now we haven't really changed this yet because we have to reduce it. What can we reduce here? What can we simplify? Now that it's in factored form, so you have to be careful. We couldn't necessarily simplify here because we have a monomial and a binomial, right? So it has to be factored first before we have two separate monomials. We can simplify monomials with monomials and identical binomials with binomials. So 12 and 18, can you simplify that now? Yeah, what can we divide both of those by? 6. So we're going to divide the top and bottom by 6. Because it says we want to make 3 equivalent fractions. So we'll just do one thing at a time. 12, what's -12 divided by 6? -2x cubed. And then what's 18 divided by -6? +3, yeah. X squared, 1 plus x. What else can we simplify in this expression? The x's. X cubed divided by x squared. X. So these, it's like we have 3 x's here, we have 2 over here. So when we cancel out 2 of them, we're left with 1x, right? Just 1x. I don't know how else to write that. So -2x all over 3 times 1 plus x. Now, could we have simplified the x's and the 6 at the same, like divide by 6x squared both here right off the bat? Yeah, we didn't have to do them separately, but they want us to write 3 equivalent expressions. NPVs. When we state our non-permissible values, you always have to go up before cancellation. So factored form before cancellation. Because guess what? One of our x's cancel out, but still in the original expression, we can't have x as 0. Because then we'd have 0 plus 0, which is still 0. So we always have to go back to the original before cancellation, the factored form before cancellation to find our NPVs. So what can x be? -1, and when it's a monomial, it's always 0. So comma, x can't be 0 and -1. Well, I shouldn't circle this. So in today, what we're going to do is we're going to simplify rational expressions. So we have to be able to factor and state our MPVs. That's our goal. Okay. We good to move on? I think that is a yes. Highlighter. Okay. So key idea is a rational expression can be simplified by factoring the numerator and denominator. So we want to factor the numerator and denominator and then divide both by their GCFs. Okay. A rational expression is in simplified form when the GCF of the numerator and the denominator is 1. So there's nothing else that is like we can factor out. The numerator and denominator, that can be simplified. The MPVs must be stated before the rational, okay, well that's, there you go. Before the rational expression is simplified to ensure all restrictions of the variable are included. Because sometimes things will reduce out, and so if you look at the final thing, you might miss some MPVs. Okay, because it's all based on the original expression. Let's simplify. So I'm going to show you 2 ways to simplify this morning. One way the notes in the workbook uses, and then just kind of getting quick without breaking it down in so many steps. So I'll show you both ways. The first way is basically figuring out, okay, is there a greatest common factor between the numerator and denominator? Something we can divide both, let's start with our numbers, negative 24 and 18 by. 6, yeah, 6, and then what else is in common? X squared. So we're going to change this to 6x squared times something divided by 6x squared times something. Basically factoring out the GCF, the 6x squared. So what times 6 equals negative 24? Negative 4, and then we already have the x. So would this, if you multiply these together, would it be your original? Yeah. Okay, what times 6x squared would give you 18x cubed? 3 and a x. Okay, so now what can cancel out? The 6x squareds. They actually reduce to 1. Anything divided by itself is 1. So that's why we show it as cancellation, because it's really just 1, and 1 times anything is just that, whatever you're multiplying it by. So now what our simplified expression will be negative 4 over 3x. So that's one way we can simplify. Comma, we need to say our restrictions. So you can look original, what can't x be? Whenever it's a monomial, it's always 0. X can't be 0. Okay. Now another way you can simplify this, it's really doing the same thing. It's just we're dividing both by 6x squared. And I'm going to show you with your calculator because a lot of you, it will be helpful. But basically, it's the same idea. What can we divide 24 and 18 by? 6 again. So then what's negative 24 divided by 6? Negative 4. And what's, remember we did this a little bit last day? 18 divided by 6 is 3. Okay, so we can literally reduce our numbers right there just by dividing them by 6. And then 6x squared divided by x cubed, what will happen? Will there be an x on the numerator and the denominator? Right, so 2 of these cancel out 2 of these guys. So this just changes to an x. Kind of a fast way of solving it. I'm going to do both, okay? So now we have on the numerator just a negative 4 over 3 times x. X can't be equal to 0. And as you get faster, you'll be able to do that in your head almost. Now with your calculator, can your calculator reduce fractions for you? Yeah. Everyone grab their calculators. Uh-oh. Open up. There you go. Okay, how would I reduce negative 24 over 18? Obviously, we can't do the x's. How do you reduce that in your calculator if you wanted to check your work? Just type it in your calculator, negative 24 over 18, and then math, enter, enter. Okay, so negative 4 over 3. So right there, you can also check our answer, negative 4 over 3, and then the x squared divided by x cubed would just be an x on the denominator. Okay, and that can help you. The monomials, we did a lot of these in grade 10, right? Simplifying with exponents and such. It's been a while, you probably forget that. It's like 2 years ago. Okay, 18 x to the 4th divided by 36 x to the 7th. What can we divide both those numbers by? 18, yeah. Now if you can do it in multiple steps and keep reducing, so first dividing it by 2 and so forth. But we can change this to, what's the 18 and what else is in common? X to the 4. Okay, so we're going to change both into a product with 18x to the 4. So what times 18x to the 4 equals 18x to the 4? Just what? You can even write that there if you like. Okay, and what times 18 equals 36? Start with that. 2, and then we're going to have x to the cubed. Remember, we add our powers when they're the same base being multiplied. And now what can cancel out? 18x to the 4, so we're left with 1 over 2x cubed, and x can't be equal to, looking at our original, 0. Okay, could you have also used your calculator to help you? Yes. 18 over 36, math, enter, enter is 1/2. Right? If you have 4 x's on top, 7 on the bottom, by reducing that, we'd have left over a 3 on the bottom. Okay. Questions? You're all quiet this today. Yeah. Okay. Now, binomials. A little bit different, right, than a monomial divided by a monomial. So our first step in these is we're going to have to factor before anything can cancel. So what can we factor out of the numerator? Is there a GCF? That's a 5 and an x. Okay, so 15x cubed divided by 5x. 3x squared. And what's negative 5x divided by 5x? Minus 1. Okay. So there's 2 ways we can approach this. Do you want to do the other method where we make 5x times? Yeah, sure, let's do that. So 5x times what gives us 15x cubed? 3 and x squared. And so what cancels out? The 5x. So we're left with 3x squared minus 1 all over 3x squared. I'm going to write a note in a second. What's our MPVs? Yeah, x can't be 0. Okay. Common student error. We're going to write a little note here. So 3x squared minus 1 over 3x squared cannot be simplified. Why? There's no, what have we been factoring out all this time? What do we call that? The first thing you check for when factoring. GCF. There's no GCF. There's no greatest common factor in all the terms. So what do you think a common student mistake is? Yes, crossing out the 3x squared. So common mistake is they'll go like this. Okay? Maybe I'll do that in red. Let's see a little better. They'll cross out the 3x squared and they'll say, oh, it equals -1. Can we do that? No. Okay, here's a way how I explained it years ago. And sorry if it's disturbing. Remember on the numerator, there's invisi brackets, right? So that 3x squared minus 1 is actually attached to that. 3x squared and the minus 1, they're together. They're a unit. It's like the arm. -1 is the arm. If I cross out the 3x squared, we're literally ripping limbs off that body. Okay? Morbid? Yes. Okay? We can't rip it off. It's attached. So binomials, only identical binomials, can only cancel itself. Like if I had x plus 2 divided by x plus 2, then yes, that can cancel each other out. That can reduce to 1. Okay, when we have a binomial, it's going to be reduced. It has to be divided to reduce it out with an identical binomial. And then only monomials with monomials can be reduced. Right? That's why we're factoring it out. We could have also solved this problem when we factored out 5x, 3x squared minus 1, all over 15x squared. See, these two are monomials, so we can reduce those, right? We can divide both of these by 5, so 1, 3, and then the x divided by x squared is just an x on the denominator. It's only monomials with monomials. This is attached. Do not try and rip limbs off. It's very cruel. Okay? I don't know if that is a way you'll remember it. We'll try and figure something out. Okay, let's look at this guy. First thing we have to do is factor, GCF, yeah. What can we factor out of the top? What can we divide both those by? 3y. So 3y divided by 3y, 1. Anything divided by itself is 1, minus 9y squared divided by 3y. 3y all over 6y squared. So now that we have a monomial factored out, can we reduce these two? So 6y cubed, thank you. The reason why we can reduce is now we change it into a product to a, let's say a times b divided by c. In BEDMAS, does it matter the order in which you multiply or divide? No, even though it's in BEDMAS, what is it? Division before multiplication, right? It doesn't matter. If you have just multiplication and division in an operation, you can multiply a times b first and then divide by c, or you can divide a divided by c times b. It's the same thing. And so the reason why, now that we've changed it into a product, we can take care of this division now. Okay? So what can we reduce here? Do you want to change it into 3y times, or do you want to simplify? Just go straight into simplification. Simplify? Okay. So 3 divided by 6, what does that reduce to? What can we divide both those numbers by? Let's put it that way. What can we divide 3 and 6 by? What will go into 3 and 6? 3. So 3 divided by 3, 1. 6 divided by 3, 2. Okay, 2. Y divided by y cubed. It'll be y squared where? On the denominator. Okay, so in the numerator, do we have to write those brackets now that he's 1 times 1 minus 3y? No. 1 minus 3y divided by 2y squared. We have to say our NPVs. Y can't be equal to, it's a monomial in the denominator with a y, 0. So far, so good? Yeah? Okay. Let's look at another one. Simplify the following rational expression. Do you want to try this on your own? Okay, together then. What can we divide 6x squared and negative 8x by? 2 and x. Okay, so we're going to factor out a 2x. So divide, if you have to, right, we're dividing both of these by 2x. So if that helps you just to write divide by 2x to figure out what's inside, then do that. 6x squared divided by 2x. Well, 6 divided by 2, 3, and x squared divided by x is x, minus just a 4. The x's will cancel out. Okay, on the bottom we have 3. This would be a cubed. Can you write, is yours say cubed? Yes. 3x cubed minus 4x squared. So what can we divide both those by? And x squared we can pull out. And we're left with 3x cubed of 3x minus 4x squared divided by x squared, 4. Okay, what cancels here? One of the x's, so, and they'll be left with 1x where? On the bottom, because there had more there. What else cancels? 3x minus 4, because these binomials are identical. These can reduce to 1 as well. And now we're just left with 2 over x. Okay, we have to do our NPVs. Where are we going to look to see our NPVs? The bottom before cancellation. So this is where you're looking to see what are my NPVs when it's in factored form before it all canceled. What are my NPVs? X can't be equal to, for the x squared, what would that be? 0. How about the next one, 3x minus 4? 4 over 3. Remember, it's opposite sign, second over first. That's all, as long as the x is first. Or, what else could you do to figure that out, to solve that? Set it equal to 0 and solve. Right? So if you're not positive, just set it equal to 0 and solve for x. Add 4, divide by 3, and there's your answer. X can equal 4/3. Okay, because that's what would make that 0. Okay, you guys ready to try the next one? Okay, try it. Your turn. Done? Yeah. Do you want to come up and do it, Andrew, or no? Here's a little hint I'm going to write down below, or I wanted to talk about this anyways. Where did I write it? Okay, well, it's right here. So this might help you in this problem, okay? Is x minus 3 the same as 3 minus x? No. Nope, 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 nope. Okay, notice here 3 is negative, here 3 is positive. Here x is positive, here x is negative. So how can we make them the same? factor negative 1 out. And so answer to this is factor negative 1 out of 3 minus x. So if I factor negative 1 out, basically we're dividing everybody by negative. What happens when you divide everybody by negative 1? Your sign switch. So then the positive 3 becomes a negative 3, and the negative x becomes a positive x. Okay, so if you run into that situation, you just might need to factor out a negative. Did you guys finish now? Just a moment. I'm going to go over it now. Okay. Thanks, Stacey. Where are we? Okay, here we are. What can you factor out of 3a cubed minus 3a squared? What's in common? 3a squared. Okay, so 3a cubed divided by 3a squared. What's left over? Just a minus 3a squared divided by 3a squared is 1. Yeah, a minus 1. On the bottom, who factored 12 out? Yeah? Is that where you guys did first? So if you factor 12 out, you get negative a plus 1. So these are close, they're just opposite signs. So how can we make these the same? Factor a negative out on the bottom. So we're going to make this a negative 12 instead. And so negative a divided by negative 1, positive a. 1 divided by negative 1, minus 1. So now what? What cancels? The a minus 1s. This one. What else? 3 and 12. What can we divide both those by? 3. So 3 divided by 3, 1. Negative 12 divided by 3, negative 4. So we're left with 1 times a squared times 1, or just a squared. And then negative 4 times 1, negative 4. How was that? Okay. Okay, what are we missing here? Common mistake to forget, MPVs. We always have to have our MPVs. We often forget. Where am I going to look for my MPV? Before cancellation in factored form. So a can be equal to 1. There's your final answer. Okay, so homework today, 4.2 in the workbook, and Ashley, I'll print it out for you for now. Yeah, so it's on page 94. Actually,
no, just kidding. Oh, no.
Yeah, so 94, you can omit, because it's an exact replica, repeat, you can omit 35 and 27. Number 4, A and D. Number 4 and AD is like, I think it's number 1, A and something. It's a repeat. So 4, A and D. Okay, the solutions are on schools on the website. So while you're working through them, you're welcome to pull that up, right? If you have your mobile devices or something. You also need a rubric. Okay, so a couple of you, I will print off what you need. Let's just stop this.